Okay, my friends, let's get started. We're at exactly one past the hour. I like to give people 60 seconds just to get in here and join us as quickly as they can. But we are thrilled to have you with us here today on the program. Chase and Marcel have already turned on their cameras. Gentlemen, you look great. How are you doing today?
Doing great, Marcus. Excited for
Outstanding.
this presentation.
Wonderful, wonderful. So what is this presentation? Well, Field Notes is a free webinar series from AMOT where we work through some of the real problems engineers and operators are hitting out in the field. It's just a straight conversation about what's failing out there and what to do about it. And today's topic is one that I know is near and dear to a lot of people in the audience. It's why automate the red zone and how to do it. So let's go on to our agenda slide here so that everyone knows, has a feel for what they can expect over the next several minutes. Before I start asking Chase a bunch of questions, just some housekeeping notes we want to go over here. Today's program, we actually did a dry run yesterday, came in right around 35 minutes. So we're going to aim to do that as well today. But feel free to ask questions. I'm sure this probably isn't the first webinar that you've attended. You've got a question panel right there. You can raise your hand if you like, ask questions within the chat. We'll be monitoring it during the program, and if we don't get to it right in the middle of the program, we've got a dedicated Q&A section at the end. We recognize that you might have colleagues that couldn't attend today's program, so yes, absolutely, the program is being recorded. We'll make sure you get a recording. We'll make sure you get the slides, everything that you've come to expect from a webinar in 2026. Oh, and one more note. If you would like language support, you can go up to your controls at the top there. You can actually load some closed captions, and you can pick a different language if that would be your preference for today's program as well. So we are thrilled to have everybody with us today. I think I've gone through all the housekeeping stuff there. Here's our agenda. We're going to be talking about what is driving the shift to automation in the red zone. I'm sure you've all been hearing about it. I'm sure some of you are facing it. But then we're going to talk about, okay, if I want to actually automate in the red zone, well, what's that actually mean for my equipment choices? And what are some of the challenges it creates? And how maybe can AMOT help me get past those challenges? So that's what we'll be talking about today. It's going to be a lot of fun. I'm looking forward to this one. Hey, Chase, I'm gonna start you with a softball, my friend. Look, the people on this program, as I take a look at the people that are attending here, they know a lot about the industry, right? But let's talk about this one and keep it really simple. When we say red zone, what exactly are we referring to?
Yeah, Marcus. So, we put the graphic up there and kind of highlighted the physical area of what is the red zone. But to put a description behind it, I mean, this is the area of operation where equipment and field teams are under extreme conditions. So hazardous area classifications, high shock and vibration to your equipment, talking extremely pressurized lines, and then temperature extremes on both the high and the low end.
Yeah, I think everyone knows it. It's a tough place to be, right? You're talking about extreme heat, constant vibration, etc. Look, the red zone, it's not a great place to be if you're a human being. That's why we talk about safety a lot as we're talking about the red zone. We'll be talking about that more today. But quite frankly, it's also just this challenging environment for all the equipment as well. So why in the world would we even want to automate in the red zone in the first place? And Chase, as you were explaining it to me, there's kind of three big drivers that we talk about, right?
Yeah, so this is feedback we've heard from location, out at the yards. The main driver is its economics. So, if you look at LinkedIn throughout the week, you'll see service companies posting about continuous pumping hours. They're all fighting to have that continuous pumping and being able to brag about that. So when you look at automation, it does cost more upfront, but where it wins is over the lifetime of the equipment. So we're talking less maintenance, fewer failures, less downtime, and I think most importantly is less manual human intervention.
Right.
And so that kind of ties us into our second point here is safety. We don't want individuals in this red zone area. I was talking about the high pressurized lines. You have all these pumps tying in at the same area. It creates a very dangerous environment. And then lastly is company policies. So this may be out of some operators and service companies' hands. This could be coming from the top down. So the E&P companies as well as the service companies are now implementing in their policies that there will be nobody in the red zone during active pumping hours.
So when we talk about all these three things, there are three real drivers, right? More uptime means more productivity, obviously more safety. That's a huge deal right there. And look, even if you're not pursuing those things, although I think everybody on the call probably is, lots of times we don't have a choice, right? It's being written into the standards, written into the specs. Now, you and I have talked about this, and lots of times when companies do webinars like this, a vendor can feel like we're trying to push a trend that's out there. But the reality is that this is a trend that's really here, right? We're seeing this in the marketplace with a lot of companies, right?
Yeah, absolutely. And like I mentioned, we're hearing this from out in the field. So, I mean, if you look across a lot of the majors, this is a push that they're already making. So we've seen it from basically every major upstream well service company.
Yeah, I think our next slide, we actually get into that a little bit. I mean, look at all these companies that are doing this right now. Tell us a little bit more.
Yeah. So, I mean, for example, the one right there in the middle next here, I believe it was 2 weeks ago, they had a whole podcast come out about a team that they've built around automating frac. So, they're using different analytics, AI to kind of automate that whole process. And then on the equipment side, SLB earlier this year, they released a cambered frac fluid delivery system that is now all electric. So again, using that automation to keep people out of that area and streamline that process.
Yeah, it's interesting when we see these names up here, one company does it, that's interesting. Two companies, well, that's something we should be curious about. But when you see these big names on the board, look, it's really happening. You've got a lot of big players are doing it right there. They've all got multi-year contracts behind them. So look, I think at this point it's kind of clear. We've already talked about why are the main reasons that people would want to automate in the first place. It's the economics, it's the safety, and we don't often have a choice. But the second thing that we're seeing here is that the big companies are really doing it. So let's say we want to automate in the red zone, and let's now get a little bit more into the valves and the actuation itself. Historically, there have been about three ways to do this, and I'd like you to walk us through all three of those and what really happens when we try to deploy them within the red zone.
Yeah, absolutely. So I'll throw a fourth one in there that's actually not listed on the screen. We'll call it our baseline, which is manually. So I
Right.
talked earlier about manual intervention. You're going down into the red zone, turning on this butterfly valve, requires an operator going into that hazardous area. So that's the baseline. And then as we move towards automation, we're starting to see first pneumatic. And the feedback we hear a lot is pneumatic is a cheaper option when people are trying to automate. But I think it looks cheap at first, and then you consider the infrastructure behind a pneumatic actuator. You have compressors, filters, dryers that all are a part of making sure that that actuator actuates out in the field. And so we put an example up here of one of our customers out in the Permian who was sitting there chasing a pneumatic issue for 4 hours. And so what it ended up being was just a filter downstream of the valve. So nothing tied into the actual actuator itself, but kind of a small component that led to 4 hours of downtime. And then like we talked about earlier, stop and pumping hours.
Yeah, but before we go on to the next one, let's just talk about that. 4 hours. Interesting conversation we had last week with one of your customers, and he's talked about how that pressure in terms of how many hours of pumping a day they used to be at and where they're trying to be now. I mean, what he was telling us was, 10 years ago, we were all going for 18, 19 hours a day. And now we're trying to get to 22, 23. So that clearly can eat up those, you talk about somebody losing 4 hours, that's kind of a big deal, right?
Oh, absolutely. I mean, they're counting every hour.
Right.
So
Right.
any time you can take that back is definitely a win in their books.
Another way we can do this is hydraulic. Wait, what can you tell us about that?
So hydraulic is a lot of the times the next step. People seem to think more reliability on that end. But even with hydraulic, you run the risk of enhanced maintenance out there. And so due to these high vibration, extreme conditions, you're talking hydraulic fluid contamination, hydraulic fluid leaks. And so that creates its own hazardous situation within itself.
And I think, on our previous slide, we had some 5 big companies up there that are making changes. And SLB is a great example, right? Because they specifically, when they came out with their Cameron fluid system earlier this year, they specifically called out that they wanted to replace hydraulic actuation. So that's another example there where companies are making the choice to say, hydraulic just doesn't cut it for us anymore, right?
Yeah, no, absolutely. It's eliminating a bunch of different risk once you get rid of that hydraulic system.
Right. So then we've got pneumatic, we've got a hydraulic, and there's a third way. Talk to us about the third way.
So third, for this presentation, we'll call it standard electric. And so when operators move this direction, I think from a reliability and accuracy standpoint, it's probably a step in the right direction. But what we've seen a lot of times is the electric actuators that a lot of these service companies are going with were not intended for the oil field. They were not meant for upstream frac operations. These actuators were meant for plant floors or manufacturing facilities, not, mobile, high vibration, extreme conditions. And
Right.
so we had a customer up in Canada who outfitted their whole fleet with 140 electric actuators. And their feedback to us was every single one of them failed. It wasn't
Wow.
one, it wasn't 10, it wasn't 20. Every single actuator, standard electric actuator, we'll call it, failed out in the field.
That's amazing and it's stunning. And of course, if we go back to what each one of those meant, whether it's downtime or maintenance, that's not a great situation. And we'll be talking about why that happened up in Canada and why it might be happening in other places for different reasons as well. So look, there's an obvious tension right here. We've talked about this. We're all trying to move toward automation. We're seeing that pneumatic, hydraulic, and standard electric. If that's your true goal to get automation in the red zone, these things aren't keeping up. So a couple of years ago, AMOT sort of looked at this and said, well, we need to do something different. So what did you do?
Yeah, so I would say about 5 years ago, the initial engineering and development started on creating an actuator that could withstand these type of environments. And truth be told, this started out as a program for one of our engine OEM customers. The intention was not to take this to upstream oil and gas, but that's kind of the road it led us down as we're out visiting customers for, a lot of folks on this call probably know us from air intake shutoff valves. We've been doing that for 30 years. So what started as those conversations quickly turned into electric actuator conversations. And so we took lessons learned from that air intake shutoff valve side of the business and implemented those designs into this design, or in this actuator design.
And it's really interesting. And on the last side, you kind of told us how we're thinking about this. We're referring to this as rugged electric. But we're going to spend some minutes here going through the specs, because if you think back to those failures that we've talked about and why those failures happen, the reality is this product's been built from the ground up to respond to some of those challenges out in the field. So let's talk about vibration first.
Yeah, so I mean, this was the big thing for us. Again, those lessons learned from the air intake shutoff side, we know the vibration this kind of equipment sees. So when we go into design this, we essentially have to create our own vibration test to see if it can withstand this environment. So we're looking at a 14.1 GRMS vibration profile test, so for 14 Gs, and this is across frequencies of 10 to 1,000 hertz on 20 hours in each axis. So this is a tank from a vibration standpoint.
I know we've got a bunch of smart people on the call today, but how would you compare that to what you see with standard actuators out in the market?
Yeah, standard electric, as we've been calling it, 1 GRMS to 5, and 5 is pretty uncommon. So I would say like in that 1 to 2 range is what we see as far as what standard they're testing to right now.
Marcel, I'd like you to come off mute here for a second. I'm not gonna make Chase do all the work today. But I think it's funny. We've got this rated test here, And the reality is, if I were to ask you, who did you send this to get tested? Tell me about it.
So we have a fantastic design engineer team local here to Houston who came up with this equipment, built it here in Houston, and we have a partner that we work with on a lot of our other testing protocols that are testing out these actuators for us.
Outstanding, outstanding. And my understanding is there wasn't a third party that you could find that knew how to do this, right? So your team had to figure it out themselves.
Yes, sir, that's correct.
Outstanding. So that's the EH series and vibration. And I think we would all agree that when we're talking about automation in the red zone, vibration is a big piece. Let's talk about waterproof. Let's talk about submersion, Chase.
Yep. So that example we were mentioning earlier of the 140 actuators that have failed up in Canada, a main reason for that, the feedback we heard from the customer was water ingress. So, we looked at vibration first. Second, okay, how can we protect this thing from the other elements within the field? So if you look at a standard actuator, it's an IP67 rating, pretty standard across all electronic components. But we knew that wasn't cutting it because there were plenty of actuators that had that rating that were failing out in the field. And so what we looked at was the IP69K rating. So this is protection against water ingress, dust ingress, as well as a high pressure washdown situation.
Yeah, and Marcel, you were talking about this yesterday. The reality is maybe I can get an actuator to a standard electric actuator to be fine out in the field, but washdown's a big part of the business, right?
Absolutely. I mean, these frac applications, there's tons of dust in the air. There's just, and a lot of the equipment gets coated, gets dirty, gets muddy, and this equipment needs to be kept in as best condition as possible to make sure it's reliable. So they'll bring them in on occasion, spray down with a high pressure hose to make sure that their equipment is clean and work properly.
Outstanding. So we've talked about vibration. We've talked about water and high pressure washing. By the way, please feel free. We do have a handful of questions that we'll be getting to in just a few minutes, but feel free to ask other questions within the chat as we go through that. Chase, let's talk about the one that whenever I'm working with you folks and I think about South Texas in the summer. Let's talk about temperature.
Yep. So, as we come across applications in the Eagle Ford or the Permian, or even up in Canada, your variation of temperatures that this actuator is going to see is all over the place. And so that's what we had in mind here, was having an actuator rated for those negative 40 days up in Canada, and then all the way up to, in the Permian. If there's reflections coming off other equipment, just the ambient air itself, you're seeing upwards of 100, 150, 200 F. And so, with this actuator, we have it rated at a negative 40 C to 125 C conditions. And so this has been tested at 100% load, a million cycles at both ends of that temperature spectrum.
That's amazing. You've tested it at a million cycles, and in a few minutes I'm going to be asking you about experiences with some of your customers. But it seems like as we go through these specs, I have to ask it now. How many warranty claims have you guys seen?
Zero.
Zero warranty claims. So it's amazing to me the product has been built to these specs and it's really performing out in the field. Now, we're going to talk about just one more feature of this particular product, the EH series. And Marcel, I want to ask you about this one again, because I think what we find is if people are curious about electric actuation, one of the concerns that always comes up is speed, right?
Yeah. When we're out in the field visiting with customers, that's one of the things they mention. Hey, we've tried these electric actuators in the past. These electric actuators are just too slow reacting for what we need. Safety being the main concern for operators, making sure my people are safe, making sure our equipment is protected. We need something that acts a whole lot quicker. So as we talked about earlier, this is a different animal. Our electric actuator meets some of the closure speeds that you see with hydraulic and pneumatic. And you don't have to worry about the downtime we talked about, or the extra equipment like compressors and filters, or the leaks from hydraulic actuators as well.
It's interesting, and I don't want to get you in trouble with your engineers, but we've got this rated at 4 to 6 seconds. But I think you've told me that in the field, you've even seen it be faster, right?
We have done some testing, and we believe we can get a quicker actuator. But yes, we're not publishing that just yet until field trials are tested completely.
Absolutely. Wonderful. So
Marcus, are you trying to get our engineering team in the Q&A chat?
yes, I am, and feel free to tell me where we are on that, folks. But no, hey, listen, if you need, why do I need to push the specs on this? The specs on this thing are incredible, Chase. I mean, this thing truly is a tank. It can stand up to anything. And that's kind of the interesting part of this conversation. So as we, let's pull up this next slide, Chase, and realistically, what we have here is we truly have created a new category of product, right?
Absolutely. We went through our 3 or 4, if you like to call it, with the manual actuation baselines. And so, as you mentioned, this is within its own category. So what we'll call our rugged electric category that we've developed and designed here.
I think it's really interesting when we think about the red zone, right? And we've got it right here on the slide. You've got vibration, you've got heat, you got all these things that happen in the red zone, and it does expose every weakness. But for you guys, it sort of drove innovation, and this product that you've designed and put out in the market, it truly exists in its own category, which is just really, really stunning. So let's talk about what happens when you're in a totally different category, right? When we look at this, it looks like an electric actuator. So it would make sense that I would compare it to an electric actuator, but then it's got much higher performance specs. So I'm going to assume that it comes at a price premium, but that's if I'm comparing it to other electric actuators. And you've helped me understand, Chase, that that's not really a fair comparison. Why not?
No, and as we've mentioned, we've created essentially our own category of actuator here. And I think it also ties back to why people are choosing automation in the first place. And so when you choose an actuator of this caliber, or this category, if you will, you're essentially eliminating the replacement cycles, which helps reduce that unplanned downtime, reduce labor costs, and then allows for continuous pumping to happen.
Yeah. So it's when we think about this, this to me, this slide I think really kind of shows that okay, it's an electric actuator, but replacement cycles, downtime, maintenance labor, those are all things that are part and parcel with every standard actuator that's out there. And you're taking them off the table, which I think is really amazing. Now, I think whenever we look at a product like this, obviously, when you're talking about, if I were to put this, in an environment where it's not going to be tested, it would kind of be a mismatch. But this product's been on the market now for a few years, and you have very quickly figured out where this product fits. Let's go to our next slide here, and this includes frac customers, but it goes beyond that. Where's this product being used?
Yeah, we mentioned earlier this started out as an engine OEM application. And so it's quickly expanded to other, what we'll call mission critical applications. And so this is being used on mobile, not stationary equipment. And this spreads to the mining industry with those, hot, dusty conditions, military and defense applications with mobile, rugged, high vibe environments, as well as fracking, as we've talked about today.
Yeah, and I think that's a huge point, obviously, when we're talking about total cost of ownership, cost, and things like that. This product it's truly rated for these really harsh environments. And so you think about it, right? I'm not going to wear a deep diving wetsuit to wash my dishes, right? I don't need to do that. But by the same token, if I'm going to be going down to do some spot welding on an underwater rig, I'm going to be wearing the right equipment for that. Exact same thing here. So now I'm curious as we get to our final couple slides here on this. It's interesting, right? Because people on the call are like, okay, gee, I've never really evaluated what a rugged actuator would look like in my environment. You guys have been at this a long time, helping people figure out how solutions work for them? What's the process look like with AMOT?
Yeah, it's similar to the first image we showed on that the intro slide, is taking a look at your red zone, your area of operation, identifying exactly what valves are still being manually actuated. And then next we ask that you choose the worst one. We want your problem actuators, your problem valves, problem applications. And I think that's where we want to start this trial, because we want you to trust that this thing is going to do what we say it does. So put it on your worst ones, trial it out, and then after that, everything goes as planned. Then we can look at upfitting the whole fleet.
I absolutely love that. Marcel, how do you help your customers find the worst place to pilot it?
Hey, let's have a conversation. Let's go out and see locations if needed, and tell me what you have. Right, just have a conversation about it.
Outstanding. All right, we're going to go now to our very last slide and move on to Q&A. Happy to answer any questions that come in. Obviously, Chase has already mentioned that, we want you to trial it out. We want you to trial it out on your absolute worst case scenarios, recognizing that every application is different. That QR code up there will actually take you to the EH series on the website. And I know we might get questions about specifications. We might get questions about CAD drawings. And my understanding, Chase, is I can find all that stuff right on the webpage, right?
Correct. Yeah, we've got some 3D models available. That way you can see how it fits into your current design. And as you mentioned, a couple different options when it comes to communication protocols, torque requirements, mounting options. So that's why it's best to reach out. That way we can look at the full design and spec out the correct actuator.
Outstanding. So another question I have for you, Chase. So we haven't talked at all in this presentation about torque or different options that are out there, but I know there are a few. So go ahead and share with me what we have.
Yeah, as of right now, we have 125 Newton meter option, which is around 1,100 inch-pounds, and then a 25 Newton meter option as well.
Outstanding. I mentioned this before, but when you're working with customers, Marcel, let me ask you this one. It's not quite at the point that it's set it forget and we just mail you one in a box and you just go. Talk to me about different options that exist for mounting.
Certainly, and I mentioned earlier about our design engineer team out here in Houston. We work daily with our customers to understand, what do you need? What does your mounting place look like? Your mounting brackets, your stem. We'll help design these brackets that are as needed. We'll create 3D models if needed and share them with you, that if you decide to manufacture those on your own. But we're here to support you with whatever you need, and our design team is fantastic and willing to help.
Outstanding. Other question, Chase, that I want to talk to you about is, obviously, I think what I've been hearing from the team is there are a lot of this product is newer. It's been on the marketplace for 2 years, but you're always actively looking to your customers. Now, listen, I don't want to get you in trouble with the engineers on the phone, but I'm sure there are other things that you're thinking about as this product continues to grow. I'm not asking for lead times. I'm not asking for any specifics, but how can we think about this product, say, a year from now? What are we thinking is going to happen with it?
Yeah, I mean, there's a couple different options that we're looking at. You talk about hazardous area. It's exactly what this is, upstream oil and gas. So, there's talks of hazardous area classifications and those certs required, different speed ratings, like we mentioned earlier, different torque ratings. And that's why it's important when you come across those problem actuators that you have out in the field already. We want to know about those applications, because it may not be something we have today, but it's something we can place along that product roadmap.
Outstanding.
And Marcus, can I add to that real quick?
Please.
Yeah, one thing I'm pretty excited about is again, talking to our customers in the field. They're talking about the dimensions of the actuators they have, and a lot of them are large. This one is not quite a cube. It's 8 by 9 by 10 inches tall, so fairly small. However, we're working on an even more compact design, which should be ready towards the end of this year.
Outstanding. Wonderful. All right, I was actually, that was the final question I had for you, Marcel, was weight and specs. Now, one other thing that I just want, a final question that I have here. If there's any other questions that want to come in, please submit them in the chat. The final one that I have though is obviously when we talk about actuation, Chase, the question often becomes up, well, controls. How am I actually going to control it? We didn't really address that in this presentation. Is that because we can work with anything that's out there, or how would you answer that when the question comes from a prospect?
Yep. So when it comes to communication protocols, we essentially have every option available and we can work with you. So this includes a 0 to 10 volt signal, 4 to 20 milliamp, which is very common. We have CAN J1939 protocol, which is also increasingly becoming more common. So basically, whatever you're working with currently, we should be able to tie into.
Outstanding. Chase Bailey and Marcel St. Marie, thank you so much for your time today. This has been a fun one. The EH series is something that AMOT has had, and it's been primarily, we've seen it over on the OEM side now for the past 2 years. But we're seeing customers like folks like you on the call today. They're like, tell me more about this one. And Chase and Marcel, you've done a great job to introduce it to us. So thank you for your time today. I really appreciate it.
Absolutely.
All right, for our folks on the call, we will get you the recording. We will get you the slides shortly. As a reminder, you can go to amot.com/EH-series to see the product-specific page for this. There you'll find the spec guides. You'll find videos. The same. I think we've got the same videos that Chase just shared with us, where they're just beating the tar out of this thing, and it performs. So it's a wonderful, wonderful product. Hey, thank you so much for joining us today for Field Notes. For everyone on the AMOT team, I'm Marcus Grimm. Have a great day.